Okay, number 3, picking up where we left off yesterday in 5.6. Hey, last day of notes for the year.
Yay. Oh, wow. Yeah.
There you go.
Nice.
The bright side. As I was just saying, we're going to do 3, 4, and 5. I'm going to forego 6 and 7. Just because, and it's not that they're not good problems, they're just, there's a lot to them. And I think it would just really, I'm more concerned about getting what I would say is a more basic problem. 3, 4, and 5, while complex, fall more into the basic category, where 6 and 7 are, oh my goodness. So, okay. An open box is being constructed from a piece of sheet metal, 18 inches by 30 inches, by cutting out squares of equal size from the corners and bending up the sides. What size squares should be cut to make a box of maximum value? And then what is the volume? Okay. You're given a fun little diagram over here. Now, for reference, not that we have maximized the volume before. However, we have worked with this situation in both Algebra 2 and Pre-Calc. Okay, where you have, in this case, it's a piece of sheet metal. The corners are being cut out. You're going to fold up the flaps, and you're going to make a box. Okay, that's what we're looking at here. They tell us it is an 18-inch. That's a weird 8. 18-inch by 30-inch piece of sheet metal. Okay? So we have that information. Cutting out squares from the corners. So each of these corners, you're going to cut out a square, equal size, then bend along the dotted lines. That forms your box. Now, do look at, what are they asking us? What size squares should be cut out to maximize volume? So always check and see, what are they asking me to do? We're trying to maximize volume. And then, yeah, in the end, we'll ask, what is the volume? So, we're being asked to maximize volume. We need a formula for volume. What do you know about volume? Okay. General idea of a box, length times width times height. Now, okay, what about our box?
And
the box does not have a length of 30 and a width of 18. The piece of sheet metal does. And what are we doing? We're cutting out squares. Do we know the size of the squares? No, that's what we're trying to find. So this square that we're cutting out here, I'm going to say that this square is x by x. Does that make sense? I don't know where the best place to put my x's is. But in other words, basically what I'm saying is this distance along here is x. This distance along here is x. Does that make sense? Okay, so it's an x by x square that you're cutting out. With that in mind, thoughts on the length of the box?
30 plus 2x.
30 minus 2.
Oh.
The length of the sheet metal is 30. We're taking away those two lengths of x, and we fold up those sides. And so that means that here, this length is going to be 30 minus 2x, yes? So length, 30 minus 2x. What about width? Yeah, because now we're going to take away this x, and that leaves in the middle here 18 minus 2x. What about the height of this box?
X.
Because it's going to be the flap, right? You fold up those flaps, and those flaps have a width of x. So that means we're going to have a height of x. Excuse me. Okay. Our job is eventually to figure out what x is. What x that will maximize volume?
So take derivative.
We're going to have to take the derivative to maximize volume. Now, do we want to take the derivative in this form? We don't have a product rule for three things even.
No.
Okay. What's going to be easiest to do here?
Uh,
Multiply it all out, distribute everything out, and then we'll take the derivative. The derivative will be easy, at least that way. I personally am going to FOIL my two parentheses, and then I'll multiply the x in on the next step. If you're talented enough to do that all in one step, more power to you. 30 times 18, or 3 times 18 and tag on a 0. That would be 20 times 18. 318 should be 540, I believe. And then I'm going to have 30 times negative 2x. So there's negative 60x. Negative 2x times 18, negative 36x. So I'm going to go with negative 96x plus 4x squared for my length times my width. And then I'm going to distribute the x if you haven't already. 540x minus 96x squared plus 4x cubed. Okay? Just practicing our algebra skills there. Now, we're trying to maximize, right? So we want to look for the derivative and find those critical points. So take the derivative. Okay. I guess in my notes I went ahead and flipped my derivative around in the order, but... Okay, what are we going to do with this set derivative?
Set it equal to 0.
Set equal to 0. As you look to setting it equal to 0,
Factor of 12.
is there a GCF of 12? I believe so. Factor out of 12. Now, just because of where my next step is going, I'm going to flip my order as I go here too, because I can't do this. I need it in the right order. I would love to say. So I'm going to have an x squared minus some x plus some constant. I don't know. Minus 16x plus 45. I don't know. No one has their calculators out today. Okay, now what?
Set each equation equal to 0. Or we could factor the one, or whatever it's called.
Yeah. And is the 12 going to matter? The 12 isn't going to matter. So all that's going to matter here, and that's just because it doesn't have a variable, gosh, is the x squared minus 16x plus 45. What?
9 and 8.
No. Yeah.
No.
Multiply would be 45 and b.
Sorry.
So, wait.
Nine-
What's happening?
nine-
I'm factoring, but I can't factor.
It does not work.
I say 1 and 45, 2 doesn't work, so evens are out. 3 and 15, 4, 5 and 9, 6, 7 doesn't work, 8's even. Those are your choices.
5 and 9 is the closest.
Don't.
But,
It does not work.
so, plan
Oh,
B,
does that mean we have to do that one thing?
depends what that one thing is.
What?
No.
So, in my notes, I did quadratic formula because it's a go-to that we just know. However, I do also have in my notes written, or you could complete the square. Okay. So, now, quadratic formula, folks, you got to know it.
Yeah.
Your calc, you've just got to know it. They're not providing it. They're not babying you. I'm not providing it. You've got to know it. So, negative b
Plus or minus.
plus or minus square root
B squared
b squared
minus 4AC
minus 4ac
all over 2A.
all over 2a. Augie knows it. Go listen to the song. Find a song, listen to it. Remember it. Write it down, look it over every so often. Okay. You might want to calc there, just saying. This lesson might go a little quicker if you have a calculator. How's that?
Yeah, that's right.
I can tell you 4 times 45 would be 180. 16 squared is 256. Maybe? No.
Yeah.
So 256 minus 180 maybe?
76.
That's what I've written in my notes, is 76. So okay.
So I guess we can divide it by 2.
I can't divide by 2 in this form. 16 and 2 can divide, but I don't have anything outside the square root of 76 to divide by 2. However, are there any perfect square roots in 76?
Oh God. Wait. Probably, yeah. 2 times square root of 19.
Because 76 is 4 times 19, right?
Yeah, so the 4 comes out when I stays in.
So it's 16 plus or minus. So if it's 4 times 19, the square root of 4 makes it 2. Square root of 19 all over 2. So now we can divide both by 2.
Wow. That's crazy.
Okay, so now, and I'm going to write these as separate, and I have my reasoning coming up. 16 over 2 is going to be 8 plus or minus
Square root of 19.
square root of 19, right? Now, so that means we're going to have 8 plus the square root of 19 as a possible answer, and 8 minus the square root of 19 as a possible answer. Yes?
Yep.
Now, in a situation like this, we always need to check, are these valid answers? Are these valid answers that can work in this scenario? And with that in mind, okay, these are x values, right? So these are x values that have to work on the corners here, right? Keeping in mind that we had a set 18 by 30 inch piece of steel. That doesn't get any longer. Okay? So calculator wise, what is 8 plus the square root of 19? It's what'd you say?
12.359.
Okay. What is 8 minus the square root of 19?
3.641.
I'm making the 3.
Do both of those work?
Yeah. Okay. The second one seems a little more realistic.
Second one does seem a little more realistic,
Yeah.
but is 12.359 a possibility? If it is a possibility, that
No, 'cause
means
you have to go from both sides.
I would have 12.359 here
Because it'd be 24 then.
and 12.359 there, which would be 24, which is
Bigger.
bigger than a side of 18. Do you see what I'm saying there?
Yeah.
Could we also just wait?
So, what I'm saying is this number is too big for the scenario. Okay? Well, I mean, they're numbers, okay? As Aiden says, the 3-1 seems more logical. I agree, but Is there a reason that 12 doesn't work, or does it just seem like the less logical option? Well, there's a reason it doesn't work, because 2 12s is 24, which is bigger than 18. Okay? So, the only answer that works is the 8 minus the square root of 19, or the 3.641-ish. Now, with that in mind, we need to be able to show we're trying to maximize volume. Is volume truly maximized at 8 minus the square root of 19? Okay, so what I'm going to, how do we talk about that? Think about a sign chart. What is our one critical value that we're going to talk about? I'm going to list it as 8 minus the square root of 19, but we did find it to be approximately 3.641. Okay, and this is a sign chart for the derivative, right? V prime. Now, we don't have a factored form to plug into here. So really what I would say, plug into, I don't know, the 12 is not going to matter. Maybe plug into right there. And just see, and you can even use like 3.6. Does that make sense? Because all I need to know is it positive or negative. So if I wanted to plug in and say 3.6 squared minus 16 times 3.6 plus 45. I just need a ballpark, right? Because I just need to know, is that going to give me a positive or a negative? And that right there, when I plugged in positive 3.6, I got 0.36, which is barely positive. And then if I plug in, wait, why did I use 3.6? I should have used, oh my goodness, I'm having a moment. I mean, 3.6 is, I was trying to plug this exact number in for some reason. Don't ask. We need a number below 3.6, yes? It works, it does. But could you also just plug in like 1 or something? That would make more sense. 0, I'd be careful, because once we get below 0, we're in numbers that, could x be negative in this scenario? No. And we'll talk about our possibilities here in a moment. Yeah, I should have just used like 1. Because if I use 1, it's 1 minus 16 plus 45. Okay, I had a moment.
I thought you were just proving a point.
Yeah, no, I wasn't proving a point. So, okay, if I want to prove a point, so what, I can use 3.7 on the other side? No, use something like 4. But on the other side, what do we get?
Negative.
You get a negative, right? No, I just had a moment of, I don't know what even to say. Okay, so my derivative was positive and negative, which means my original graph is increasing and decreasing, which makes this indeed a max. Okay, that's your justification there, is what we're doing. Now, one thing that we didn't talk about, and I guess I probably should have talked about over here after we found our x values, in a scenario like this, you do need to consider domain in terms of what are the possible x's we can use. Can I use anything below 0? Could x be negative? No, because it's a length here, right? So that domain, it has to be a number bigger than 0. And then it has to be a number less than, well, if you look at this right here, that 12 was too big earlier, wasn't it? If we do 18 minus 2 times 9, that gets your 0 there. So really, this has to be a number between 0 and 9. It's not that you have to write down the domain, but I encourage you to think about what logically works. Okay, so that's just, kind of food for thought, what logically works there. Okay, so what size squares should be cut to make a box of maximum volume?
8 minus square root of 19 size.
Squares that have a size of 8 minus square root of 19 by 8 minus square root of 19?
Inches.
Okay, inches. And then it also asks us to find the volume
Oh, yes, it's like that.
of the box, which, now here's the deal. Do we have a volume formula?
Yes.
Yeah, we have 3 different versions of the volume formula depending what you want to use. Well, my original, once I FOILed and once I distributed the x in. Pick one and plug in 8 minus square root of 19. Okay? And then we'll write out some information here.
Okay. 886.593.
I agree. I'm just getting it punched into my calculator. So you punch into the calculator, you eventually get 886.553. What would that label be?
Inches. Cubed.
It's volume, so always inches cubed, or always cubed. In this case, it's inches. So that right there, what is the volume? We answered that. We answered it. I have it written down, but what size squares should be cut? And there we said I'm going to say squares with sides of 8 minus the square root of 19 inches will maximize volume. And my justification there is that the derivative changes from positive to negative. Since v prime changes from positive to negative. Okay, so there's my other official answer. I know we have to take into account getting back from lunch and everything, but I feel like this is the halfway point of class. But it's a little bit before halfway. We've gotten through one problem.
The first half always goes faster.
It does. It does. I agree.
And now it gets kind of slow.
Okay, guys. Here's your problem. Do you have everything you need? Because I'm going to talk about the bottom of the page here. Okay. The bottom of the page just has it says strategy, some guidelines. Okay. Not necessarily steps. You have to do them in this order and everything, but, some key things. Read the problem carefully. Underline key information. This also means reread the problem multiple times. Yes. And I know you guys are calc. You've made it this far. You're not the type that just, word problem, move on. But take that time, reread the problem multiple times. Draw a picture where possible. Label everything you know on that picture. Okay. Write a primary equation, an equation that gives a formula for the quantity to be optimized. So like right here, the question was, what was it asking? It was asking us to maximize volume. So that means we needed a volume formula. Okay. Identify the constraint or limiting factor. Write a secondary equation, an equation that provides information needed to complete the primary. We didn't have this in this one. We did yesterday where we had to write 2 equations sometimes and then combine them. When you have to write 2 equations, which we will, I believe, on the next one. Yesterday we had to do it like on the pasture. We had to write a formula for perimeter and a formula for area. One of them we solved for a variable to put into the other, so we just have one variable. That's what they mean by secondary. So solve the secondary so you can plug it into the primary. Determine a feasible domain. That was demonstrating this last one. Just sometimes there are numbers that are not logical. Okay. Find your derivative. So your derivative, critical values. Determine your absolute extrema. Be able to justify. Could we have just assumed once we only had one value that that's the max? You pretty much can. Because if it asks you to maximize and you only get one value, yeah, pretty much. But doing the sign chart is your justification there. Okay? And then answer the question in complete sentence using appropriate units. Free response. They're not just looking for an answer. A lot of times you need words to go with it. Okay? Okay, let's step over to 4. Okay. So in the last few examples, we were guaranteed that the functions had absolute extrema by the extreme value theorem. Let's explore a few situations for which the domain is neither closed nor bounded. I'm not really sure that it's going to change anything about how we do this, though. So, okay, I'm going to give myself a little bit more room here. What are the dimensions of an aluminum can that uses the least amount of aluminum? Assume the can is cylindrical and capped on both ends.
Oh, it's gonna
Okay.
So we're talking volume.
Okay, so, well, there's two things we're talking here. What are the dimensions of an aluminum can that can hold 40 cubic inches? Is that where you're getting volume from?
Yeah.
Okay, so we know this can hold 40 cubic inches. I'm gonna go ahead and put that over here. That we know volume is 40 cubic inches, yes? Okay. Now, the other thing is, what is it we're trying to maximize, minimize? We want the least, we're trying to minimize, least amount of aluminum.
So,
We want the least amount of aluminum. What is that?
smallest.
For like
How would we?
So, okay, volume is what the can
Smallest.
holds, yes? We're not trying to minimize volume.
Smallest.
Perimeter
trying to minimize that.
Area.
What'd you say?
area.
Area,
Surface
specifically
area.
surface area. Okay, so we're trying to minimize surface area. Okay, now they gave us the volume information because we're going to use that. That's going to be our secondary equation. Our primary equation is the surface area because that's what we're trying to minimize. Okay, so let's talk. I tend to use SA for surface area. However, you could just use S, you could just use A, I don't know. As I look at my notes, I changed it up to S of something here a little bit. Okay, we need formulas for both surface area and volume. Let's start with what is the volume of a cylinder? I always say if it's a volume of a prism where the ends are both the same, it's base times height, but that is the base is the area of the base times the height of the object. Not 2 pi r squared. Area of a circle is pi r squared times the height. You're thinking circumference. But it's just 2 pi RH, or 2 pi r. Too many variables. Okay, so the volume formula that we know is pi r squared is volume. What we're going to know here in a little bit is that pi r squared h equals 40. That's my secondary equation. What I'll be able to do is solve that for either r or h, and we'll sub it into our other equation. Now, surface area. Okay, surface area is the area of all of the surfaces. So we have this can here. What do you know about the bottom?
Circle.
It's a circle, so the area of a circle is pi r squared. What do you know about the top?
Circle.
It's a circle, so
2 pi.
we know the top and bottom are going to be 2 pi r squared. Plus, I need
Like,
the can.
Yeah.
Now,
oh,
think about it. You peel a label off of a can.
It's just.
It's a big old rectangle, yes?
uh-huh.
It's a rectangle that
We need circumference. Wait,
No, we need that.
it has this height,
yeah.
and what is the length of the rectangle?
The circumference.
The circumference. So what's circumference of a circle?
I just said
You did just say it.
2 pi r.
2 pi r. That's going to be one side of the rectangle. What's the other side of the rectangle?
H.
The height. So we need 2 pi r h. There's your surface area. Okay? I used to create these with my 7th graders when I taught it. But then I would give them a formula page and say, okay, here's your formula page after we created it. So, it's calc, guys. There's no formula page. Now, will they provide formulas sometimes? Yes. Okay. But you've got to know some of the basics. Okay. So, surface area is our primary formula because that's what we're trying to minimize. Right now, it has r and h in it. I need it in terms of one variable. Well, I have my secondary formula over here, my volume formula, where I know what it equals. But it's also in terms of r and h. So, in our surface area, which one's easier to get rid of? Probably the h, because there's just one h, right? So take your volume formula and solve it for h. So we can then plug it in over here, and it'll be in terms of r. So what is h according to volume? 40 divided by pi r squared. Is that the form I used in my notes? It is. Okay, so now we're going to rewrite our surface area formula. In my notes, I wrote it as S of R because it's the surface area formula, and we're getting ready to write it in terms of R. 2 pi r squared is going to stay 2 pi r squared. Plus 2 pi r h is going to be 2 pi r times 40 over pi r squared. Okay, I would like to clean this up. 2 pi r squared is still 2 pi r squared. Plus, what about this end mess?
Could we 80 pi r over pi r squared? And then
Clean it up more.
we could take one of the pi r's off the top and then
Oh, and then it's just. Oh,
Pi cancels with pi.
So it's just 80.
1 r on top cancels with 1 r on bottom.
so it's 80 over r.
I like it.
Oh, there's no.
You good with that?
Yeah.
Now, I am going to rewrite it one more time because this is our primary, which means I'm going to have to take the derivative. So what about that 80 over r?
80 r to.
Yeah, so I'm going to write 2 pi r squared plus 80 r to the negative first. Okay? Okay, we have our formula.
Yes.
Okay? In terms of, I know one of the things it said thing about domain, we're talking about radius and height and surface area and volume. They have to be positive, right? That's really about all we have happening here. So let's try to minimize, which means I'm ready to take the derivative. I'm going to move over here to the left and make use of all my room. Okay, thoughts on the derivative?
1 pi r.
4 pi r.
Negative 80 r to the negative second.
Okay, so I'm going to change it to minus 80 r to the negative second,
Why didn't we have to do product over 5?
because pi is not a variable, pi is a number, it's a constant. So it just goes along with the 2. Okay?
That's it.
If I rewrite it one more time, 4 pi r minus, this is what, 80 over r squared? And I'm just doing that because what do I have to do next? I have to set my derivative equal to 0 and try and find any critical values, yes?
Okay. Well, r equals 0. Okay. Good.
Say add the 80.
Yeah, I would say add the 80 over r squared over so that you have 4 pi r equal to 80 over r squared.
What do we solve for?
We have r we're trying to solve for. What'd you say?
Multiply by r squared.
Okay, to get r squared out of the denominator, multiply by r squared. So then we're going to have 4 pi r cubed equals 80.
Divide by 4.
I would go 4 pi, get it all done in one piece.
That's
So 80 divided by 4 pi could also be written as, what is 80 divided by 4? 20. So we could write this as 20 divided by pi, if you will. Not that I should really put that equals there next to it, but.
cube root.
And then we're going to cube root, yes? So r is going to be equal to the cube root of 20 over pi. Okay?
Do we, when r was still in the denominator, do we not have to set that equal to 0? Like the last one?
Because the derivative would not exist at that point.
Yeah.
So, okay, so I don't have that noted in my notes, which is interesting, which means that she probably didn't note it in her notes. But the question is, when we looked at, yes and no is what I'm going to say. So when we looked at the fact that right there, Aiden's pointing out that r could not equal 0 right there. Or I guess what I really should say is r squared equals 0, which means r equals 0. So is that a critical number? Well, the one thing I would say is what's going to happen if the radius is 0?
Does lose the
Circle.
This doesn't exist. Okay? And so that's where what's going to happen is, even though I said there's really not any domain restrictions other than it can't be negative, it also can't be 0. So it has to be anything greater than 0, just not greater than or equal to. So that would be, yes, I agree, we probably should consider it, but in this scenario, it's not going to make logical sense. Does that make sense? Okay. For the record, let's double, what is r as a decimal? I mean, we're going to keep using the cube root of 20 over pi, but what is it as a decimal?
1.85.
Okay. I'm not encouraging you to start using 1.853 for specific pieces, but okay, is that a logical answer? Yeah, that could be logical, right? It's not negative, it's not 0. You know, it could make sense for a volume of 40, that type of stuff. So we're okay there. With that in mind, we should double check. Is this truly a, what are we trying to do? Minimize. Okay, so if I set up a sign chart here, the one critical value I'm using is the cube root of 20 over pi, which is about, gosh darn, I'm too close down here, 1.853. Okay. And right here, this is where the 1.853 is helpful, yes? because a number below 1 and a number above 1, or 1.8, okay? And again, we are plugging this into S prime. So S prime, go back to one of those two formulas is what I would say. I'd plug in what, 1 and 2, is that what you're using?
I'm using one.
Going off of my mistake from earlier, using 1.85. Hey, that is to the left.
I got negative first.
Negative on the left.
I agree.
So it's
Okay.
probably gonna be positive.
And you can't assume.
Okay. And this is why we're doing this, because officially, should we assume? No. Okay. You need to be able to justify. Now, and I will say, we just talked about that. If I look on my notes here, I have 0 written here as the left boundary. Not that 0 is a critical number, but 0 written as my left boundary is, and we can't go below 0. So, if this is negative and positive, it's increasing, decreasing, which then that does create a min. So I can feel confident in saying that. Now, like all good math students, go back, reread. What were the questions? Question.
Dimension.
What are the
We have radius. We don't have
dimensions?
Oh, come on.
Okay.
Are we going to go back and solve it?
No. We have it. We have what we need.
Oh.
No problems. We have, okay,
Wait, just plug in the R.
we have radius right here, yes?
Yeah.
Radius is good. Check it off the list. How do we find height? Plug in R to an equation where you already have h equals, yes? H equals 40 over pi r squared is what we found earlier. Don't reinvent the wheel. Use the work you already did. So that means I'm doing h equals 40 over pi times the cube root of 20 over pi quantity squared. Don't use the decimal here. Unless, okay, here's the one way I'd say you could use the decimal. The other way you can use a decimal is if you go back up and grab the full decimal from above. Like when we first found that 1.853 number, you could use that. That would be the one thing I would say.
See how close we got. 3.708.
I have 3.707 in my
I
notes.
also have
That
Wait,
mine hurts because
He used the rounded version, he said.
Ah, you cheater.
it takes me one so slow. It's 0.001 off.
Right.
Yeah.
Which, and here's the deal.
3.7.
I'll get you a question wrong.
That's 1.5.
There are no half points on the AP
That's the
test.
difference between you
Well,
getting a 2 and a 3 on your AP.
I mean, and here's the deal. If you have done all of this right, do you want to miss a point on this problem
No.
for something stupid like that?
Take it serious.
Nope.
Okay. I mean, it's one thing if you were just lost on the problem, but hey, if you know what you're doing, you don't want to miss something like that.
I managed to
This
get
one
this
will be the
far.
first
Okay?
Finish.
Okay, guys, so I have written down the can measures. Did I say it that way? Yeah. I have radius, 1.853 inches, and height, 3.707 inches. And how do I want to say this?
to have a volume
Yeah, let's see. They won.
with the least amount of movement.
Yeah. And I guess what I have is, actually what I have in mind is something along the lines of when S prime of R equals 0 and changes from negative to positive. Okay.
I don't think we'll get more.
One more time. Or what? One more.
I know, we're still supposed to do number 5.
Oh, gosh, 5.
And how long did it just take us to do number 4?
20 minutes.
20 minutes.
Yeah, exactly.
I'd say more. Yeah, probably 20.
We got 9 of these too, so
Well,
it's gonna be 5 hours.
Yeah, but we can.
Homework might take me
We know already. Learning it takes long.
it does. It takes longer with me leading you through it.
Will the homework problems be similar to these?
Yeah,
That was the goal.
20.
Yeah.
Okay,
Sometimes she teaches you something great,
Let's do a homework problem.
here's what I'm going to say.
honestly.
Well, we're not, reality. Are we going to make it through 5? No, we're not going to make it through 5. That's reality. So, I had already planned to skip 6 and 7. So we're going to call it quits here. Now, what I am going to tell you is in homework, I had already written down to tell you to skip number 7. And now, since I didn't just do that one, I'm going to tell you to skip number 8.
Oh, it's a dream.
Merry Christmas.
Okay.
Christmas
Final,
came early.
final lesson.
Sorry, you went from 9 homework problems to 7 homework problems, which is still a lot for this stuff. But
Yeah, it's still.
I took out a couple of the harder ones.
Thank you.
Okay? So, we're stopping here. And I'm going to say skip numbers 7 and 8 on homework. See what you can do with the rest. Okay?
Dang.